Okay, so we're supposed to fill out a Venn diagram. And up here, they say that 25 of the students take online classes, so 25 are in event A. That means the probability of event A is 25 out of 50, because there's 50 total students. 25 meet this criteria, so 1/2, the simpler way. Probability of B was 35 over 50 for the same reason, and that simplifies to be 7 over 10. Okay, so they tell us that the probability of A given B is 15 over 35. So the probability of A given B, that's equal to the probability of A and B, and then divide by the probability of B. And since we already know the probability of B is 7 over 10, we can solve that equation. You get 15 over 35. That should equal the probability of A and B, which we don't know. But we know probability of B from what we just did over here. That's 7 over 10. So kind of yucky with a fraction there. The way I'd rewrite that, well, first let's simplify over here. 15 over 35, that's 3 over... why can't I do that? 35 divided by 5 is 7, right? This is the probability of A and B. And this is divided by 7 over 10. So a better way of writing that would be to flip and multiply. Okay, so now to solve that equation for probability of A and B, we can multiply 7/10 to both sides, right? And so the probability of A and B, these should cross cancel. It should be 3 out of 10. We can do the same thing with this one, but we should get the same thing because probability of B given A, that's the same thing as probability of B and A, which is actually the same. If you say the probability of going to lunch and getting hit by a meteorite, that's the same thing as saying the probability of getting hit by a meteorite and going to lunch. So the order doesn't matter there. So if we were to plug in probability of A, we should be able to get the same thing, and we could just double check that. Divide the top and the bottom by 3. Oh, by 5, I mean, sorry. And then over here, this is probability of A and B. And then the probability of A is 1/2, so we're dividing 1/2. That means we're multiplying by 2 over 1. So you can multiply both sides by 1/2 to get that by itself. So you get 3 over 10 equals probability of A and B. But, so like I said, that didn't matter because we already knew what the probability of A and B is. It's 3 over 10. We already got that from the other one. Okay, so they want the number of students. We can get that really quickly from the probability. So let's start with the intersection, just like we usually do with Venn diagrams. So the intersection is A and B, right? We found out 3/10 of the students meet this criteria. So you multiply that by the total number of students by 50. So 50 divided by 10 is 5. 5 times 3, that's 15 in here. And then this over here, let's do A first. Let's say this is A. We can find out the number of students. Wait, they already told us. Online is A, and it's 25 students. We just need to subtract the intersection. That's 10 over here. And same thing over here. B, they told us, is 35 students that are freshmen. But 15 were already in the intersection. So when we subtract those two, we get 20. So 20 fits over here. And if these don't add up to 50, then the last number needs to be on the outside. So 10 plus 20, that's 45 inside the circle. So that means there's 5 left over that are neither of those two criteria. There we go. We filled out the Venn diagram now.